Welcome to True Projects. In this video, we are going to explain about a project titled A Deep Learning Based Intrusion Detection and Preventation System for Detecting and Preventing the Denial of Service Attacks. In the realm of computer security, intrusion detection refers to the capability of identifying and flagging the instance of unauthorized entry into a computer network. Such access poses the significant risk to the confidentiality, integrity, and accessibility of both the computer system and the data it holds. The significance of intrusion detection within the computer security is paramount, necessitating the development of more advanced tools to not only uncover but also effectively respond to the instance of unauthorized entry into the computer network. This project delves into two primary strategies employed for intrusion detection: signature-based detection and the anomaly-based detection. Moreover, this project explores the limitation inherent in applying machine learning techniques to the intrusion detection. While ML offers the potential to enhance the detection accuracy, it introduces the certain complexity. For instance, the risk in misclassifying the malicious data packet as harmless are concern that demands the vigilant model, training and the evaluation. The aim of this project is to create an advanced intrusion detection and the prevention framework known as DIQ, which leverages the capability of the deep learning to effectively identify and thwart the denial of service attacks. The system outlined the meticulous process undertaken to select the most suitable algorithm for the accurate detection of DOS attacks and the detailed comprehensive development of the software designed to identify and counteract these malicious activities. In the pursuit of efficient defense mechanism against DOS attacks, the proposed classification model adopts a multi-layer deep feed-forward neural network, and it plays an pivotal role in facilitating the training as highlighted. And the operational functionality of the function system revolves around the interception of data packets from the network interference. These intercepted packets are subjected to the judicious classification process, effectively segregating them into two categories of malicious and benign. This classification occurs in real time, highlighting the system ability to swiftly analyze the incoming data. Furthermore, the system showcases its capability to present the crucial packet details, such as of timestamp, source, and destination IP address. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 for Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, we need to import the necessary Python libraries such as NumPy, Pandas, Seaborn, Matplotlib, sklearn, TensorFlow, and other relevant libraries too. These will be used for data manipulation, visualization, machine learning, and the deep learning tasks. And the second one is exploring the dataset. Here we need to load the dataset using the library of Pandas, explore the dataset structure, columns, data types, and the statistics within it. And the third one is data processing. Pre-process the dataset to handle the missing value, outliers, and noise. Perform the data normalization, scaling if required. This step ensures the data is suitable for the training machine learning model. And the next step is visualizing using the Seaborn and the Matplotlib. Using the libraries of Seaborn and the Matplotlib, we create the informative visualization, generate the various plots, histogram, and the graph to gain the insight into the data distribution, correlation, and the pattern within it. And the next step is label processing. If your dataset has containing of the categorical labels, encode them into the numerical value using the technique like of label encoding. And the next step is feature selection algorithms. Apply the feature selection technique to identify the most relevant feature for our model. This step helps in reducing the dimensionality and improving the model performance by focusing on the essential attributes. And the next step is splitting the training and the testing data. Split the pre-processed data set into the testing and the training set. The training set is used to train the model, while the testing set is used to evaluate the performance. And the next step is building the model. Here various machine learning algorithms and deep learning algorithms are built. The first one is random forest. It is an ensemble learning algorithm that combines the multiple decision tree to improve the combination of the classification and regression accuracy. It handles both the numerical and categorical features effectively, captures the complex relationships and data without overfitting, provides the feature importance scores to aid in feature selection. And the second one is SVM. It stands for Support Vector Mission. It's a powerful supervised learning algorithm used for the classification and the regression task. Effectively classify the network traffic as a normal or the potential attack based on the decision boundary. Handle the high dimensional data through the use of kernel tree. Handle the imbalanced data by adjusting the class weight using the technique like smoothie. Provide the good generalization performance if properly tuned. And the next one is XGBoost classifier. It is an optimized gradient boosting algorithm that excels in the classification task. In our project, it handles the missing data and the outliers. It manages the imbalanced class through the built-in features and provides the interpretable result through the feature importance plot. And the next one is voting classifier. Voting classifier combines the multiple individual models to make the prediction. In this project, it combines the support vector mission, random forest, and the decision tree. And the next one is CNN plus LSTM. It combines the convolutional neural network plus the long short-term memory network. It's a powerful approach for sequence-based data like of network traffic. In this project, this combination can automatically learn the hierarchical features from the raw data, capture the both spatial and the temporal patterns in the network traffic, achieve the state-of-art performance in the sequential data analysis, handle the varying input length through the LSTM memory cell. And the next one is CNN. CNN stands for Convolutional Neural Network and is widely used for the image and sequence analysis task. In our project, the CNN can extract the local and the global features from the network traffic data, detect the pattern and the anomalies in the traffic flow, handle the high dimensional data efficiently through the shared write and the pooling layer. And the next one is LSTM. It stands for the long short-term memory with a type of recurrent neural network well suited for the sequential data, and in our project it captured the temporal dependency in the network traffic, handle the variable length sequence and manage the long-range dependency, and learn and retain the relevant information over the time through the memory call. And the next one is attention anneal. Its mechanism enhances the capability of the neural network to focus on the relevant information and dynamically weigh the different parts of the input data for the better feature selection, highlight the important segment of the network traffic for the accurate intrusion detection, and improving the model interpretability by visualizing the attention weight. And the last one is TorchNN. PyTorch neural network is a popular deep learning framework, and it provides the flexibility and the customization in the model architecture, utilize the GPU acceleration for the fast training and the inference. And the next step is the user gives the input. The Flash web application is used to take the user input, create an interface where the users can input the data related to the potential network traffic or attack. And the next one is the given input is pre-processed per prediction. The user data is in the similar manner as of the training data. Apply the same data processing step such as normalization and the encoding. And the next step is trained model is used for the prediction. Load the trained model that demonstrated the best performance during the evaluation. Pass the pre-processed user input through the model to obtain the prediction. And the next one is, and last one is, the final outcome is displayed. The model prediction to the user through the Flash web interface. This outcome could indicate whether the input data presents a potential denial of service attack as of banking or not. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the folders like CSS, JavaScript, font, images and assets within it. And the template folder containing of the HTML documents like of about, home, index, notebook, sign in and sign up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations, such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model files are contain the algorithm information and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the signup.db is a file appear to be the database file that will be used to store the user information. And the test case file will be used to test the performance of the model. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder's path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime checks for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this address and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. And pasting this link, and we can see that the title of the project and containing of some information about it. And then click on the get started now button. Click on the home sign up button. Here it will redirect it to the sign up page containing of some details that are need to be filled to create an account. But my account is already created, that's why I am using the sign in button. Here it will redirect it to the sign in page containing of username and password and those details that are need to be filled with you. And then click on the login button. Here it will redirect it to the index page containing of some details within it that are need to be filled. And I'm entering the DST port as of 3389, and the total forward package is of 8, and the flow IAT minimize is of 4, and the flow IAT mean is of 23798200. And the forward IAT standard is of 390108, and the ECA flag count is of 1, and the forward set size mean is of 20. IDLE standard is of 0. And then click on the predict button. Here it will redirect it to this result page, and viewing the result as the attack type is of Bengal based on the CSC CIS 2019 data bank. In this way we can predict the DOS attack. And by clicking on the home button, here it will redirect it to this page, and here we need to enter the other details to refill with to give the attack within it. And in conclusion, we summarize the contribution of work, which include the selection of the most appropriate deep learning algorithm for detecting the denial of service attacks, the development of deep learning based intrusion detection and the prevention system called IQ, and the testing of the system using an offensive system called Diluvio. In this, we explained the proposed DOS attack classification model uses a multi-layer deep feedwater neural network, and the CICD-DOS 2019 dataset was used for training, achieving the best accuracy, recall, and FM score.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.